All right, so in lesson 7 of chapter 9, we're going to talk about the different segments that are created by chords and secants and tangents, and then how to find missing segments based on the information given. Like I said in class, this is the lesson in terms of kids making the most silly mistakes. This is the one. So hopefully when I point out those errors, you can note them so that you will not make those same mistakes. First theorem in lesson 7, chapter 9, is the fact that we have two chords, they're intersecting in a circle, and the product of the segments that create the chords are equal to each other. So we have x and y, a and b, and so therefore the product of x, y equals the product of a and b. Looking at the way that the diagram is made, one of the questions in class was, how can you tell which are the longer sides? Very simply put, obviously we can tell that y is longer, and y and b are both on the right side of the circle. That would leave a and x to be the shorter sides and b and y to be the longer sides. Looking at one of the diagrams in your worksheet, on question number 4, you'll notice that they're asking you for RQ. Well, if you notice, RQ and SQ are pretty close in terms of their length. However, R and T are on the right side, and obviously TQ is longer. Therefore, RQ would be longer than SQ. And so go ahead and answer questions 1 through 4 if you haven't done so already. The second theorem takes two secants and shows a theorem where if we take the whole entire secant from point to the opposite side of the circle, the product of the external part of that secant and the entire secant is equal to the other part as long as they are intersecting. So for instance, xy, x being the whole entire secant, y being the external segment of that secant, is equal to the product of a being the whole secant and b being the external part. In your examples that you'll see, the common mistakes made are when the internal segment of the secant, or in this case the chord, is given and people multiply the chord and the external part instead of the external part and the entire secant. I'll point out an example a little later on. So go ahead and answer questions 5 through 8 on the back side of the worksheet now. The final theorem in the lesson is when we take a tangent and a secant and we use the same properties. The square of the tangent segment is equal to the external segment times the entire secant. So when we do this again, the biggest mistake is to take the chord and multiply it times the external segment of the secant and not take the entire secant. Here are some examples that follow. If we're looking for x, the setup would be taking 8 times 6 and multiplying it times 3x and x and setting them equal to each other. Solve for x by dividing and taking the square root to find that x equals 4. In this case, I'd like you to hit pause and answer the next question, solving for x and y. So in the next one, we solve for y by, solving for x by taking 4 being the external segment of the secant and multiplying it times the entire secant, which is the external plus the chord. So 4 times 4 plus 5 equals 3, which is the external segment, times 3 plus x, which is the whole secant. Solve for x that way. The other theorem takes y and squares it because it's the tangent, and then again takes the external segment and multiplies it times the secant as the same in theorem 9.12. The big mistake here is instead of doing 4 times 9, most people who make the mistake, and a silly mistake, will do 4 times 5 or 3 times x instead of adding the 2. So be careful of that mistake. Hit pause and answer questions 9 through 12 now. Being done with the worksheet, just wanted to review some of those concepts. So taking a look at this example, I want you to answer questions 1 through 4 just so I can point out those mistakes again and how they might impact your answer. Okay, so in number 1 we have the tangent 15 and then this secant, which is 9 plus x. The external segment is 9. So your setup should be 15 squared, which is 225, and set that equal to 9 times 9 plus x. When you solve for x, you should get 16. Number 2, we have two secants. The whole secant on the left is 8. The external segment is 3, so you should have done 3 times 8. And on the right, we have the whole secant being x plus 4, and the external segment being 4. So your equation should be 8 times 3, which is 24. 24 equals 4 times x plus 4, solving for x to make x equal 2. You can see how if you pick the wrong equation or even don't identify the secant and the segments as properly, you can definitely get into some trouble in terms of solving equations. Setting this one up here, once you have 4 times 4 plus x minus 3 and 5 times 5 plus x minus 6, you could solve for x to find that it equals 9. And finally, number 4, we have a tangent again with 4 plus x, just as we did up in number 1. So it's 6 squared equals 4 times 4 plus x to make x equal 5. If you have any questions, bring them in tomorrow. We will go over the answers and the mistakes again, just to make sure that, again, we are being as accurate as possible. Have a great day.